Yeah, so unfortunately, Syed won't be able to make it, so there might be a little bit of rambling and confusion, but we'll make it through this. I've got a lot to cover, so I might be talking a little quick. At the very end, I've got some QR codes that have links to this slide deck and to the code snippets I've embedded. So if I do go a little too quick, you can either reach out to me on Slack, on the community Slack. My handle is my last name, Ferruzzi, or you can download the slide deck and the code and take a look at it for yourself. So we're going to be talking about custom executor development. So the first question, I guess, would be, what is an executor? And I've got the pasted the official answer on there. Executors are the mechanism by which task instances get run. The more English version, the more casual answer is, within the scheduler loop, there is a part of the scheduler loop which actually runs these tasks. That's your executor. So there's basically two types of executors. We've got local executors and remote executors. A local executor will run your tasks locally, which is on your hardware. Whatever is running your scheduler loop will also be executing your tasks. And the other type is a remote executor, so that could be basically anything else. We're actually in the community, we're discussing new names. We're discussing a bit of a third term for an edge executor, but that's a whole different talk. So for example, a local executor, we've got 3 built into Airflow. You've probably used at least the local and the sequential executors. And like I said, those just run your task on your worker, right? The remote, for example, a lot of people use Celery or Kubernetes or the combined Kubernetes Celery executor. The executor will send your task off to another container or another server or somewhere else to execute it. So for the most part, if you're looking at making your own executor, it's pretty safe bet it's going to be a remote executor because the local ones are already covered. So why would you want to create a custom executor? There's a bunch of reasons why you might. I guess I should have included in my introduction, I work for AWS, so I'm going to be using that as an example because it's what I know. But if you are with a company and you want to run your tasks, for example, on your own distributed server, maybe you've got some confidential information you don't want leaving your network. If you are a cloud provider and you want to be able to run your tasks on your specific service, like Google Cloud or AWS or whatever your particular cloud instance is, things like that would need their own custom executors. Task startup time is one I put on there. There's a big difference on local executor and remote for your startup times. So if you're running a local executor and you've got a task that takes 2 seconds to download a file and that's it, your local executor is literally just going to download the file to your computer. But if you've got a remote executor, like what we're going to be talking about in a few minutes, I'm going to go more into it, the ECS executor that we released recently, you're spinning up an entire Docker image to download the file. Obviously, your 2-second task now takes longer, much longer. So you have to take into consideration what tasks you intend to run, and you're going to have to balance that out. I already discussed the provider. The noisy neighbors, that's another big one. If you're running everything on a local executor, for example, and you've got 3 tasks to download a file, and then 1 task that does a whole bunch of crunching and takes up your whole CPU, everything's going to come to a halt until that one finishes and frees up resources. So a remote executor can take care of that if you, depending on how you sort it out. If you end up just running everything in the same remote cluster, then obviously that's going to be the same issue anyway, but it gives you more opportunity to distribute the workload to in a way that makes sense for you. All right, so when you're making a new executor, there's basically 6 parts to an executor, which are listed here. Your start method, you're going to have, obviously you have some sort of a startup. The next step, you're going to sync any running tasks. So you're going to go through, and any tasks that are already running, you're going to check the status and then update the status. So whether they've finished since the last check, whether they failed, whether they're still running, you're going to need to figure that out. You're going to have some form of doesn't necessarily have to be a queue. You're going to have some form of new task checking, right? So you're going to have to try to run your new tasks. Adopt task instances. This one is going to be dependent on your service. In order to adopt a task, you have to have a way of reconnecting to it. So again, I'm going to be using ECS as an example. I'll show you exactly what I mean by that. This isn't something that's always going to be possible, but an example of when you would need it would be if I'm running my executor and it crashes. There are some tasks out there somewhere running. Can you reconnect to those and pick it back up once your executor is back online? AWS Lambda, for example, you don't get a current state. It's either running or it's not. So you can't really reconnect to it and pick it back up and start monitoring it again. If you don't have UUID or some unique identifier for your task, you won't be able to find it again. So that's something you're going to have to really consider whether it's applicable to your situation or not. Then, of course, you need to be able to handle any failed tasks. What you do in the instance of a failed task, what you do from there is going to be dependent, obviously, on what your needs are. And then there's two types of exit that the Airflow supports, either an end or a terminate. End is a graceful exit, and terminate is a forced exit. Again, that's going to be dependent on what you want from your executor, and I'll go through next and show you a real-world example. So this is the ECS executor. As we said earlier, every executor is going to have some up and down. There's going to be some benefits, and no executor is perfect, or we wouldn't be having 20 different executors and looking at how to create our own. So for the ECS executor, it's great because resources like the CPU and the memory, they're all individual. So every single task you run gets its own little container, its own little virtual computer. So there's no noisy neighbor issues. Every task you can, for example, can get 2 CPUs and 3 gigs of RAM, or not, whatever it is you set it up to. So you don't have to worry about that one task killing your whole scheduler. So that's one of the main advantages we were looking for when we created the ECS executor. The other one that we liked with this one is that each container can have its own separate Docker image. So if you have dependencies for certain tasks, but you don't necessarily want to load up all these dependencies every time you start a 2-second task, you can do something like that. So just as an example, these are the things that we were looking for specifically and why we came up with ECS. The downside is what I mentioned earlier. It's a remote. It's starting up a new Docker image for every single task. So if you're just downloading a file and copying it to your database, that went from like a 2-second task to a maybe 2-minute task. So it's not perfect for every use case, which is actually a really good segue into Nico's talk next. He's going to be talking about hybrid executors, where you can set a different executor for each task. All right, so we're going to dive into the code on the ECS executor. So I've already told you there's 6 main steps. And the first step is the startup sequence. So basically what we're doing is, it's going to depend on what you want to do. You can throw in a log message here saying something like starting up. We have an optional health check. So what we're doing on line 118 there is checking the configuration, seeing if the user wants a health check. If they don't, great, we're done, move on. If they do want a health check, we're going to check it for them and then report the status. So the health check is going to depend on what you want. We ended up having to run into a really weird situation here where our health check is failing the way we wanted it to. So we're running an impossible command here on line 150. We're running an impossible command here to stop a task that doesn't exist. And then we have a whole bunch of handling for the exceptions. So if it comes back and says no network connection, that's a failure. It's not healthy, obviously. If it comes back and says you don't have authorization, that's a different type of failure that still tells us something very important. If it says the cluster doesn't exist, there's a whole bunch of cases where it'll fail, and it's not healthy, but it's still useful information. When it gets to the very last step and it tries to delete or stop the task, which doesn't exist, it'll just say, task doesn't exist. We know that was the last possible step, so everything else was good. Right? So we consider that failing for that purpose to be healthy. I know you're rolling your eyes right now. If it gets to the very last step and everything else worked, except for the one step we knew can't possibly work, then we consider that a healthy state. It's a little counterintuitive. It took a little while to get our brains around it. Hopefully, if you're doing it with a different service, you can come up with a more positive spin. It worked, or it didn't. But then the important part there is down here on line 172, where we're setting whether or not the connection is healthy. And then it's going to hand off to the sync method. So the sync method, as I said earlier, it's going to update the task. So we're going to look at the code here. If it's not healthy, there's an exponential back off. Keep trying it a few times, and then eventually fail out. Then the next thing it's going to do is try and sync the running tasks. So it's going to look at that in a second. It's going to try and sync up the existing running task and then try and launch the new tasks. One thing that I specifically wanted to point out here on line 219, the big red line. It's extremely important. If you are writing your own executor, the executor is part of the scheduler loop. So if it fails out and there's an uncaught exception, you will crash the entire environment. I know those of you who know Python, accept exception is terrible. We always try to avoid it. You should never use the most generic catch like that. You should always be specific. In this case, we don't ever, ever, ever want something to bubble up that we didn't catch because it will crash the whole environment. And obviously, you don't want everything to go down because one component did. There is some work being done. Hopefully, I'm not sure if it's going to make it into 3.0 to decouple the two so this isn't the case. But for now, keep that in mind. So the first part that it did is to sync the running tasks. So like I said, it's going to go through here. It's going to go through the active workers. It's going to get all the ARNs. If you're not familiar with AWS terminology, that's just a unique identifier for a resource. It's like a UUID. So it's going to go through all the active workers. It's going to look through all of the existing running tasks. If there aren't any, great, congratulations, you're synced. But if there are any, it's going to describe the tasks. That's going to return all the information, including the status, whether it's running or not. And that's going to drop a log message and then go through. If there are any failures, then we're going to call handle fail tasks, which I discussed earlier real quick. We're going to look at that again later. And then update task here, you have to store it. Whatever your response is here, whether it's running, whether it's still finished, or whether it's still running, you have to store that somewhere. That's what we're doing down here at the bottom on update running tasks. So that was the sync method. The next one that we discussed was to try to run new tasks. This can be handled a lot of different ways depending on how you want to do it. You could use a queue. You could use however you want to line up your tasks. That's up to you and what your goals are. But here we can see we're popping off of the queue at the top there. If it's not time to run it, put it back on the queue. So we're trying to run it, checking the next attempted time. If it's not time to run it, put it back on the queue. And then we try to run it if it is time. We have a whole bunch of different exception handling in here. Again, this is slightly truncated, but this is actual code from the Airflow repo. There's a link at the end to see all the details on how we did the error handling. The important part here is if it fails, we store the reason why. And then down here, if there is a failure, we're going to call handle failed tasks, which we discussed earlier. And I mentioned that we are able to do the adopt task instances here. So in order to adopt the task, I mentioned earlier, you need to have some way to reconnect it to find it again. And that's what the ARNs are that we stored earlier. So what this is going to do is go through, basically it's going to look at your ECS cluster. It now has a list of all of the tasks that it just launched in the last step. And it's going to go through the cluster and get a list of everything that's currently running and find out which ones it doesn't already know about. And those are the ones that need to be adopted. So whether you can do that on your planned backend is, I can't tell you that, but if you can have a way to find ones that are already going that you don't know about, this is when you would do that. And essentially that's all this is doing, is it's going through and finding ones that are running that it doesn't know, that it did specifically start. And then handling the fail tasks. So obviously, some tasks are eventually going to fail. In this case, task is a bit of an overloaded term in Airflow. We're talking specifically here about ECS tasks. When we're talking about the failure count, for example, if you try to start a new task on ECS, you might run into some sort of a problem with a network connection or a quota, service quota, something like that. So we're going to retry. So if we have retries left, we're going to requeue it. If you don't have retries left, we're going to log a message. We're going to fail the task in Airflow. So the actual DAG task will get marked as failed. And then we're going to pop it off of the active workers list. And then, like I said, there's two different ways you can handle the exit. There's the end and the terminate. End is graceful, terminate is brutal. For end, if you send an end, we're not going to start any new tasks. Anything that's currently running, we'll let kind of drift off, finish, but no new tasks get launched. And then when it's done with anything that's currently running, we'll consider it ended. Terminate, just burn the whole thing down. Every single task gets a sig term, and you told us you want it shut down right now, we're going to shut it down right now. Again, these are things to consider when you're trying to decide whether your service, your backend, is going to be suitable for an executor. You don't necessarily, I don't think, have to implement both of them, but whether you can gracefully exit versus a forced exit is something you're going to want to think about. So we've discussed we haven't discussed, I've talked at you about the 6 different steps of an executor. I've shown you a bit of code about how it gets implemented. And then, like I said, all the code snippets were from the source code on the Airflow repo. That's the QR code on the left. These slides are on the right. I redacted some lines purely just to make it fit on the slide. But you can see the actual source code there.